Okay. Today we're going to get into negative exponents. But before we do that, I just kind of want to do a quick review of what we've done so far. We've been talking about monomials that when you add or subtract a monomial, which can contain like a power. So like we have 3x squared plus 2x squared minus 6x. All right, when you're adding or subtracting, you're going to be doing what you're calling combining like terms. And we've done this before when we were solving equations. You know, when I say clean up the room on each side of the equation, that's combining like terms. All right, and when we say that, each term or each monomial has to have the same variable with the same exponent. So x squared and x squared, these are the same. So all I do is add the coefficients. All right, so we have 5x squared. Now this x has an exponent of that invisible 1. It doesn't match the x squares. So he's going to have to hang out by himself. So this would be your reduced or simplified expression. Right. Then we got into the rules for exponents. And the first rule was product rule. And what do you do with exponents when you're multiplying monomials or powers? All right. So if I have x squared times x to the third, all right, this expanded form would be x times x times expanded form of x cubed is multiplying x 3 times to itself. So if you look at this as a whole, we're multiplying the variable x 5 times to itself. So since that's what we're doing, they noticed that you can simply just add your exponents to get the correct exponent without having to sit there and expand it and count. All right, so the rule is for xa times xb equals xa plus b. So you're adding your exponents when you multiply. All right, the second rule was the power rule. And like, what if we have a power and it's to a power? So like if I have x squared to the third power. Well, since I have these parentheses around this entire power and then my exponents on the outside, what it's saying is this entire power is the base. So it's saying to multiply this power 3 times, our exponent's 3, to itself. So x squared times x squared times x squared. Well, we know if we have that multiplying powers, we add the exponents and we get x6. So what they discovered is instead of adding the exponents on this one, you would multiply. So 2 times 3 is 6. All right, so the rule is x to the a power to the b power equals x to the a times b. Okay, so anytime you see the parentheses and you got a variable on the outside, an exponent on the outside by itself, that's going to be a power to a power. But remember that this exponent applies to everything in the parentheses. So if I have 3x cubed squared, all right, so I'm squaring everything inside. So this, it's kind of like this means 3 squared times x cubed squared. So 3 squared is 9, and then x cubed squared would be 6. All right, So the square, you have to do the whole number, 3, just as normal, 3 squared. All right, and the last rule we had was the quotient rule. And that's when you're dividing. So if I have x to the 5th times x to the 4th, then you subtract, all right? Because if I had 5 x's being multiplied on top and 4 on the bottom, they would all cancel out except that one on top, right? So they discovered if you subtract numerator minus denominator, you're going to get the answer, all right? So the rule is x to the a over x to the b equals x to the a minus b. Okay? All right. Now, when we were doing this quotient rule Monday, we always came up with a positive. When we subtract the bottom from the top, we always came up with a positive. But that's not always the case. Sometimes you're going to get a negative, all right? So let's look at what if I have x to the 6th over x to the 8th? Well, that would be x to the 6th minus 8, so that equals x to the negative 2. All right, so that's what we're going to look at today. What do you do with a negative exponent? All right, the rule for a negative exponent is to make it its inverse. Flip it to the other side and it becomes positive. Okay, now let me show you why. Let's take this problem that we had up here. We have 6 x's on top, x to the 6th power. On the bottom, we had x to the 8th power. Okay, x divided by x cancels, 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 cancels. What am I left over? I'm left with x times x, or x squared on the bottom. All right, it's in the denominator. You can't just put that as the answer. That would be wrong. Your answer would be 1 over.
Mr. Dale or Mr. Kenny?
All right, you have to make sure you have it in the right spot. Okay. So really, when I'm dealing with these, I use this type of method to kind of do a shortcut, and I'll show you that in a minute. But I want you to understand that if you have a negative exponent, just put it to the opposite side of the fraction bar, and that'll make it positive. All right. All right, so let's look. If I have x to the negative 5, well, I'm just going to flip it and put it as a denominator. Since there's nothing there, that means it's like that. So you're just going to flip it, and it'll make it positive. All right, 3m to the negative 2. All right, you're not flipping the 3.
Hey, Miss Alicia Jackson.
You're only dealing with the exponent. All right, the 3 stays like it is. But we're going to put the m squared to the bottom. And you can also write this as 3 over m squared. Okay? So it's just, you say, oh, well, this one's negative. I need to put him underneath there. All right? Okay, on this one, let's put you a line. All right, the negative 7, that negative is not the same thing as a negative exponent. All right, it's staying where it's at. And then we have a to the negative 4. Well, I'm going to put it on the bottom. We're going to flip it, and it's called the inverse. All right, when you flip it, that's the inverse. All right, so we're going to put it to the bottom. And B3, it's positive, so it's staying where it's at. Okay, so this would be your answer. So everything stays where it's at. Your negatives, just put them to the opposite side. Okay? All right. Simplify each expression. Make sure you find answers containing only positive exponents. Use the rules, then move the variables at the end. All right, so when this little hint, they said use the rules, then move the variables at the end. So always wait until the last thing to take care of your negatives, because you may be doing it over and over again and you don't want to do that. So let's just wait till we get to the other to take care of it. All right, so here we're multiplying powers. Product rule is for multiplying, right? Same base, so we're adding the exponents. So we're adding 7 plus -9, so that equals w to the -2. All right, so now we're going to flip it. Okay. You say, well, what happens if I don't flip, if I flip it first? Well, you would have w to the 7 times 1 over w to the 9, which equals w7 over w9. And then 7 minus 9 is -2, which equals 1 to the positive 2 when you flip it. Okay. So if you do this first, do your rules first, it can save you some steps. But I want you to know, even if you don't, it'll still work out. All right, so we're multiplying this to this. So let's multiply our numbers. 4 times 5 is 20. And then my c's. We got c to the 8 times c to the -5. So we're adding our exponents. So that'll give me c3. And then d's, d to the -3 times d to the -1. So -3 plus -1 is d -4. So 20C3 are fine where they're at. Move D with a -4, flip it to the bottom. And that will be your answer. Okay. All right, let's see. I'm gonna do the even here. All right, 6 times -3 is -18. X to the -8 times x to the -3. Add your exponents, you get -11. So -18 is good. It doesn't have a negative exponent. It's a negative exponent makes it flip, not a negative integer. So this would be x to the 11 on the bottom. All right. 8 to the -2. All right. We're gonna write this down for right now. 8 to the -2. And then p to the 5 to the -2. So it's a power to a power. So that's going to be p to the -10, all right? All right, now even though 8 is a number and not a variable, not an exponent, it has a negative exponent. All right, so I'm going to put both of these to the bottom to make them positive. Now, I didn't have anything left on top, and I'm going to put a 1 there as a place marker to show that if I don't, then you can't distinguish that that's a denominator. Okay, so just put a 1 there. Now, I can simplify it one more time. What's 8 squared? 64. So that would be your answer. Okay. All right. So this is 3 to the -4 power, r to the -4, and s negative times negative is positive. Okay. All right, so let's draw our fraction bar. These two are negative, so they need to go on the bottom. And the S is positive, so it's going to stay where it's at. And we can do one more. 3 to the 4th power would be what? 3 times 3 is 9, times 3 is 27, times 3 is 81. R to the 4th, S 12. Okay. All right. Now let's look at this one. You got, okay, the way the rules do, I'm dividing, so I'm going to subtract 2 minus 5 gives me H negative 3, right? And then H negative 3 would be 1 over H cubed. Okay? So this is your answer. I've got a shortcut where you can skip this step. If I got 2 H's on top, and I've got 5 H's on the bottom, what am I going to have left? 3 on the bottom, right? So you can subtract the numbers and put your answer where the biggest exponent was. All right, so let's just say I have x to the 5th over x to the 8th. Big exponent, 8 minus 5 is 3. So bigger exponent was on the bottom. So it's going to be x3 on the bottom. Now, am I saying you can't do this? Yes, that's the proper rules, okay? But this is just kind of a shortcut. Once you deal a lot with these, you'll kind of get used to it. It just makes sense. I got 2 on top and 5 on the bottom. 2 will cancel out, and I'll have 3 left over on the bottom. Okay. All right. Okay, let's look at this one. Draw your fraction bar. 14 divided by 7 is 2. Put your answer where the bigger number was, 2. Then W to the 4 and W to the negative 2. Well, now I've got a negative on the bottom, right? Well, how do I make it positive? I bring it to the top, and it becomes positive, right? So if I already got 4 up there, and now I'm going to add 2 more, that'll give me W to the 6. Do I have anything left over in the bottom? No, so I can just put the numerator as my answer. All right, let's flip over to the back. Let's look at number 18. All right, let's draw our little fraction bar. Let's look at the whole numbers, or the real numbers first. Negative 4 divided by 8. All right. Well, 8 won't go into 4, but you can reduce this fraction. 4 will go into negative 4 negative 1 time. 4 will go into 8 2 times. Okay. Now, as far as the p's, I got 1 on top, 2 on the bottom. I got 1 on top, 2 on the bottom. If I take the difference, it leaves me 1 on the bottom, right? Now, you can come up here and say, okay, this is 1, and bring this up and say minus 2. That's negative 1, so I put it down to the bottom. But I think every year, everybody kind of likes just doing this better. Okay. All right, Q's. This would be 5 minus 2. So I got 5 on top, 2 on the bottom. So that means I have 3 extra on top. My R's, I got 10 on the bottom, 3 on top. That means I have 7 left over on the bottom. Okay? Whatever the difference is, put that where your biggest exponent was. Okay, so this would be your answer. All right, let's look at this one. We're adding two things, but we need to take care of the stuff first. All right, so we got 4 to the negative 2, x to the, what do we do with exponents when it's a power to power? We multiply. So 3 times negative 2 is negative 6, and 6 times negative 2 is negative 12. And then over here, we're going to have 2 to the negative 3, x to the negative 6, and y to the negative 12. Now, these are the same, aren't they? Same exponent, same variables. So we can just add the coefficients. So 4 to the negative 2 is going to be 1 over 4 squared. And then 2 to the negative 3 is going to be 1 over 2 to the third power. Well, this is 1/16, and this is 1/9. Okay, so now we got 1/16, and bring your x down, your y down, plus 1/9, bring your x down, your y down. All right, if we add these together, let's see, we got to get a common denominator. So, let's see, 16. All right, common denominator is 9 and 16. Okay, well, 9 times 16 would be 144. X6, Y12. And we had to multiply that. I run out of room here. Let's carry this over here. This would be 9 over 144 x6 y12 plus 9 times 16, so it would be 16 over 9 x6 y12. So 9 plus 16, this is 144, excuse me. So that would be 25 over 144 x6 y12. Go back to old school, have to figure those common denominators, big ones. But if you had your calculator, you could just put 1/16 plus 1/9, and it would have given you 25 over 144. This didn't change. Okay. All right, let's look at 22. Okay, remember on Monday we talked about if you have a numerator, it's got more than one term, one monomial in it, then you need to do that first and get it down to a single monomial on numerator and denominator before you divide. So we need to multiply these things first. So this is going to give me 30 a to the, we're multiplying, so we add our exponents to the 12th over negative 12 a to the 14th. Now, this negative is not a negative exponent, it's an integer. Treat it like normal. I'm just going to reduce that fraction. 6 will go into 30 5 times, and 6 will go into negative 12 negative 2 times. Then for my a's, I got 12 on top, 14 on bottom. The rule is to subtract. That would give me a negative 2, which puts the a on the bottom. If you look here, I had 12 on top, 14 on bottom. I had 2 more on the bottom than I did top, right? All right, so that would be your answer. and 24. Okay. Negative 6 squared. Negative 6 times negative 6 is 36. And then x to the 4th squared is 8. It's power to a power. We got that parentheses with exponent on the outside. That means we multiply exponents. And then y to the 6 times 2 is 12. And on the bottom, I've got negative 4 to the 3rd power. So it's negative 4 times negative 4 times negative 4. And that's going to give you negative, well, my pen won't work, negative 64. And then negative 3 times 3 is negative 9. And 5 times 3 is 15. Okay. All right, so 36 over negative 64. We can reduce that. Let's see. Or you can reduce that to, I guess, 4. So 4 we're going to 36 9 times. 4 we're going to negative 64, negative 16 times. Okay. So we reduce that fraction. Now my x's, I've got 8 on top and negative 9 on bottom. I can't have a negative on bottom. So I have to bring it up here to make it positive on top. So 8 plus 9, that's going to give me a total of 17 x's on top. I had 8, and then I made this positive, so that added 9 more of them. So I've got 17 on top. And then y's, I had 12 on top and 15 on the bottom. If we cancel out, we'll end up with 3 left over on the bottom. Okay? And that would be your answer. All right, I'm going to leave the challenge problem, and I think I'm going to let you try that. We might go over that. I will give you a hint. Work from the inside out, okay? I wouldn't worry about that until I've done everything inside. I would do this first, and then this, and then multiply them. Then I would divide by that. Those negatives, you can go ahead and bring them up to the top, make them positive. Then take your answer, which should be a monomial, to the 3rd power. Just try it, see what you do. Okay, all right, so we've got an individual practice that we'll do in class, and then, you know, Candace and Madison, y'all do them for your practice as well. And then, let's see, what do we have? What do we have after this? Let's see, we're gonna do a scientific notation on Thursday, and then Friday, for your Friday work at home, remember, Friday is a school day at home. For your Friday work is a review of all our exponent rules and scientific notation. Remember, those of you who haven't turned in your Friday work, you're still sitting there absent. All right, you're absent until I get it. All right, y'all have a good evening, and I'll talk to y'all tomorrow. Bye.